Zoom session is being brought to you by the fractal water. Okay, for today, we'll do 2-3 properties of the trigonometric functions and 2-4 graphs of sine and cosine. We start with the circle definition of the trig functions. For the unit circle, we draw an angle theta, this line to a point x by y on the circle. Cosine is x, sine is y, tangent is y divided by x, cotangent is x divided by y, secant is 1 over x, cosecant is 1 over y. All right, those are the definitions by the circle. Now, because cosine is x, which goes between plus and minus 1, cosine is between plus and minus 1. Sine is y, again, that too is between plus and minus 1. Now, okay, the reciprocal of secant is the reciprocal of cosine. And so if cosine is between -1 and 1, 0 we throw out, infinity, we throw that out. But secant is therefore less than or equal to -1 or at least equal to 1. Cosecant the same. It's at less than or equal to -1 or it is greater than or equal to 1. Cosine and sine are defined for all theta. Tangent and secant but have an x, i.e. a cosine, in the denominator. So these are defined when cosine is not equal to 0. And these will be for theta equal to 2n plus 1 pi halves for some integer n. So it would be an odd multiple of 90 degrees. And cotangent and cosecant are defined when the denominator sine is not 0. And so that would be for except at theta equal 2n times pi over 2. In other words, some even multiple of 90 degrees. An even multiple of 90 degrees ones here, here. So x is 0. So excuse me. No, here, so y is 0, and reciprocals are infinite. And at odd multiples of 90 degrees, the angle ones appear here. So tangent and secant become infinite. All right, now here's an angle, interesting identity. When we go to an angle theta to x by y, if we add pi radians, in other words, 180 degrees, we go halfway around the circle and wind up at -x by -1. So if this x is cosine of theta, then this is cotangent of theta plus pi. And since these are opposite, cosine of theta plus pi is negative cos theta. Similarly with sine, here at theta plus pi, we have a minus y and y compared to theta. So sine of theta plus pi is minus sine of theta. And they're reciprocal, secant and cosecant. When you add pi radians, you get the opposite, minus sec theta minus cosec theta. I call this a half period identity, half period of pi. They don't actually give a name, they give that name in the book, but I think it's a useful concept. So if you add 180 degrees to theta, then cosine, sine, secant, and cosecant flip to their opposites for a half period. Now, on the other hand, tangent is a sine over cosine. And in that case, the negatives cancel. So tangent of theta plus pi is tan theta. And in fact, it's tangent of theta plus any integer times pi. Cotangent is the reciprocal, cosine over sine. Again, the negatives cancel. And so therefore, cotangent of theta plus pi is cotangent theta. And, or cotangent of theta plus any integer multiple of pi. So this is period pi. You add pi to the angle, tangent and cotangent return to their original values. Now, if we, instead of adding pi radians, we add 2 pi radians, then this flips, and this flips, and this flips, and this flips twice. Therefore, you wind up back with cos theta. So cosine of theta plus 2 pi is cos theta, sine of theta plus 2 pi is sine theta, secant of theta plus 2 pi is sec theta, cosecant of theta plus 2 pi is cosec theta. Period 2 pi. And that should make sense because if you add 2 pi radians, you wind up back to where you started. So cosine, sine, secant, and cosecant of theta plus 2n pi is the original trig function for any whole number n. Now, actually, in a sense, you can say that this is true for tangent and cotangent. If you add theta pi radians and then add pi radians again, it stays back at tan theta and cos theta. So all these have period 2 pi, but in addition, tangent and cotangent. Now, here we have a angle theta leading up to x by y. And here we have this opposite theta leading to x by negative y. Same value of x, opposite value of y. Now x refers to cosine. So cosine of minus theta is cosine theta. And the reciprocals are secant. So secant of negative theta equals secant theta. This is known as an even function. It absorbs a negative. But the y flips to a minus y when we change the theta to a minus theta. So sine of minus theta equals minus sine theta. Cosecant is reciprocal sine. So taking reciprocals, you get the cosecant of negative theta equals negative cosecant theta. Tangent and cotangent are, this is sine over cosine, this is sine over sine. We take negative theta. One of these flip, the sine does, but the cosine doesn't, so the ratio becomes negative. So tan of minus theta equals minus tan theta, cotangent minus theta is minus cotangent theta. So sine, cosecant, tangent, and cotangent are what are called odd functions. They transmit a negative, whereas cosine and secant are even functions. Now there are various trigonometric identities, which we'll be using. Secant is 1 over cosine, cosecant is 1 over sine. We've seen that before. Tangent is sine over cosine, cotangent is cosine over sine. Tangent and cotangent are reciprocals of each other. These are the ratio identities. There's also the Pythagorean identity. If x squared plus y squared plus x squared equals 1, then sine squared plus cos squared equals 1. And this means the square of the sine. So there's 2. They put the 2 right next to the sign rather than, around parentheses in order to avoid using parentheses. And this is the Pythagorean identity. And there are various ones related to it. Okay. Now, signs of trig functions depends on which quadrant the angle winds up in. If it's in quadrant 1, the acute angle between 0 and pi halves radians, then all trig functions are positive. If it's in the second quadrant, where it's an obtuse angle between 90 degrees and 180 degrees, then it's above the x-axis, so sine and cosecant are positive, but the others are negative. Here in this part, between 180 degrees and 270 degrees, or what I call a breakback angle, tangent and cotangent are positive, and the others are negative. And finally, in this quadrant here, between 270 and 360 degrees, what I call a Pac-Man angle, it's to the right of the y-axis, so cosine and secant are positive, but the rest are negative. So we have some examples to do from the book. What is sine of 405 degrees? Well, sine has period 2 pi, i.e. 360 degrees. So if we take 360 away from 405, we have sine of 45 degrees. And then we use the right angle, the 1, 1, root 2 triangle. Sine of 45 degrees is opposite over hypotenuse, 1 over root 2. That's sine 405. Here they have tangent of 19 pi over 6 is what? Well, tangent is period pi. So if you subtract 3 pi from the angle, you should get the same tangent. So it equals that. Tangent 19 pi over 6 minus 3 pi. After a little bit of arithmetic, that's tangent pi over 6. Pi over 6 is 30 degrees. So we draw the 30, 60, 90 triangle with sides 1, root 3, and 2. Tangent is opposite over adjacent, therefore 1 over root 3, like that. And here they have a problem where we're given one trig function in which quadrant it is. Find all the other trig functions. All right, so sine is 12 over 13. That's y over r. Okay, opposite over hypotenuse. Now we have a 12 here and a 13 here. What's this side here? Well, use Pythagorean theorem. This side is the square root of hypotenuse squared minus other side squared. And since it's in a second quadrant, that means it's this value is negative. So it's minus of root 13 squared minus 12 squared. And 13 squared is 169, 12 squared is 144. 169 minus 144 is 25. The square root is 5. So this value is negative 5. So, okay. At this point, the x value is negative 5. The y value is 12. Now, all right, cosine x over r minus 5 over 13. And now, okay, cosecant is reciprocal sine 13/12. Secant is reciprocal cosine minus 13/5. Let's say cosine, cotangent, let's say tangent, opposite over adjacent. So that's 12 over negative, or it's negative 12 over 5. Cotangent is reciprocal, negative 5/12. They ask for what is the tangent of negative 30 degrees? Tangent, like cotangent and sine and cosecant, is an odd function. The negative sign comes outside. So this equals negative tan 30 degrees. Then we draw a 30, 60, 90 triangle with sides 1, 2, and 3. This tangent is 1 over root 3. We have a negative, so negative 1 over root 3. This tangent is negative 30 degrees. Here they ask for sine of 80 degrees times cosecant of 80 degrees. Now I never said what the sine trig values of 80 degrees are. It's probably a whole lot. So it's all right, because we know that cosecant is 1 over sine, and sine 80 times 1 over sine 80 cancels and gets you 1. This, here we have sine theta is 0.3. Then they ask for what's sine theta plus 2 pi plus sine theta plus 4 pi. Sine, like cosine, and secant and cosecant, has period 2 pi. So this will be the same as sine theta, and this also will be the same as sine theta. See, sine theta plus sine theta plus sine theta. From here, that's 0.3 plus 0.3 plus 0.3, which makes it 0.9. We have tan theta equals 3. What's tan theta plus pi plus tan theta plus 2 pi? Tangent and cotangent have period pi. So this tan theta plus pi is tan theta. This tan theta plus 2 pi is also tan theta. So tan plus tan plus tan is 3 plus 3 plus 3, which makes 9. Now this one's a bit tricky. They ask for sine of 1 degrees plus sine of 2 degrees plus sine of 3 degrees, all the way up to sine of 359 degrees. Is everything except sine 0, which is the same as sine 360. So we're not having this. But these, sine of 359 is the opposite of sine 1. So these add up to nothing. Sine 358 is the opposite of sine 2 degrees, so these add up to nothing. Everything adds up to nothing, and sine 180 is 0. So adding them all up, you get the sum is equal to 0. Now the book has one where it's cosines, and there the differences these cancel across the way. But this one, the 0 degree is missing, and this 180 degree is there. So you're going to want to, it all sums up to cosine of 180, which I'll let you figure out. Okay, I believe we are done with this part.